So thanks for having me, even online. And my name is Radu-Daniel Vatavu. I'm a professor of computer science at the Ștefan Mare University of Suceava. And my background is primarily in human-computer interaction, but I also work in various other domains that relate to HCI, such as extended reality and accessible computing, and also ambient intelligence, because there are many applications where HCI is needed in each of these fields. And even for today, I prepared a topic about extended reality and more specifically about how we can augment and extend our current sensing and cognitive abilities beyond what natural evolution can offer. So to this end, I'll present a new concept that we've been developing here in Suceava for a few years, and which we call sensory motor realities. And it is actually a distinct type of a reality in the landscape of computer-supported, computer-mediated realities that is based on the notion of ability. So I will start with a very brief definition of what abilities are, and then go from there in order to propose you and define a totally different type of reality that is complementary to augmented reality, to virtual reality, mixed reality, and so on. So sensory motor realities, the type of reality that I'm going to discuss today, it capitalizes on the diversity of human sensory motor abilities. And by abilities, we understand those organismic factors that we bring when learning a new task. And abilities represent the basis for skills, which is a term that we use to refer to task proficiency and in general, and how we can apply both effectively and efficiently our abilities to everyday life. So to give you a few examples in relation to emerging technologies today, we need very precise visual motor coordination of the arm, hand, wrist, and finger in order to accurately touch targets on the very small screens that wearables integrate, such as a smartwatch. Then there are many situations in life where we need very dexterous movement and coordination of the fingers, such as when children assemble very tiny Lego pieces forming complex structures during their play. And also, our abilities are affected by the context in which we are applied. So in this picture, you see a person that has a spinal cord injury and who needs two hands in order to grasp and use a TV remote control. And so on, when we explore the variety of abilities and also placed in context that we use every day, we realize that first, there is a diversity of such abilities, and second, that we can capitalize on these abilities in order to engage with new types of realities. So the same sensory motor and cognitive abilities that make us effective at everyday tasks in the physical world can very well be leveraged for interactions in new types of environments that we can design, develop, and deploy. And even though these environments, they all feature synthetic stimuli. So these examples show how a fundamental capacity that we have is to repurpose our existing abilities. And both the environment, but also the technology that we develop and is found in the environment, they are able to mediate these abilities in order to arrive at new skills. And for us HCI designers and practitioners, to arrive at new interactive experiences. So the concept that I will introduce focuses on this very experience where we possess a set of abilities, but these abilities can be expanded by the technology that mediate them and the environments that we create in order to mediate those abilities into new ones, including acquisition of new skills. So the content that I prepared to today, first I'm going to introduce formally the concept, which is sensory motor realities. And this is a new conceptual framework that depicts a new type of computer-mediated reality that I'm going to show has distinctive characteristics in this landscape of extended reality. And I'm going to propose you a conceptual space for defining technology, designing technology, and specifying experiences in this in this new framework where computer-mediated worlds are within our reach. And then I'm going to show how by designing extended reality environments that focus on abilities, a new type of design that touches on accessibility emerges, which I call ability mediating design. And I'm going to present a few principles about this, such as how perception and action are being mediated by the very technology and the worlds that we can design in this area. And towards the end, I'm going to present a vision, which is also a research roadmap for extending the diversity of possible computer-supported and computer-mediated realities that we know today. So, sensory motor realities relate to existing types of computer-supported realities, such as virtual reality and augmented reality and mediated reality and so on. So in this slide, I've adopted a formalism from Steve Mann, where they see these distinct realities as subsets and supersets, respectively. So, for example, you have augmented reality, which is a subset of mixed reality according to the reality virtuality continuum of Milgram and Kishino. And then you also have mixed reality, which is a subset of mediated reality defined by Steve Mann, and so on. You have the larger circle, which is multimediated reality, which includes not only interactive systems for available human senses, but also for additional human senses, or human senses that we can create by mediation of technology. So in this landscape, I define sensory motor realities distinct in scope from all the other possible realities that we know today. And this distinctive scope comes from the fact that virtual reality, augmented reality, mixed reality, and all the other computer-supported realities are agnostic to differences in human abilities. So they do not offer the necessary tools in order to understand how to design for specific abilities or how to design in situations where a user's abilities changes over time. But in contrast, sensory motor realities actually places emphasis on human sensory motor abilities, and especially how these abilities undergo mediation as we acquire new skills by using technology, new emerging technology, and by engaging in new types of computer-supported and mediated worlds. So in order to define this new type of reality, I have adopted a principled approach. So there are three principles that I'm going to present. So first of all, it is the relativity principle, which says that our abilities, or human abilities, they vary in time and in place, and generally they vary in the context in which we perceive the world and in which we interact with the world. So according to this principle, everything is relative in terms of our abilities, and each of us experiences every day a variety of sensory motor realities. Then the second principle is what I call the many worlds principle. And effectively this states that the realities that we can design, they should focus on interactive experiences in worlds that represent mixtures of physical and virtual and also imaginary, our mental models about how things work around us. And for this, distinct sensory, motor, and cognitive capabilities are needed. And third, I propose this instrumentation principle, which states that sensory motor realities, they focus on mediating abilities. So not just reusing existing abilities or plain old abilities that we have, but enhancing, expanding, extending further our abilities based on technology that we wear, for instance, that is close to our body, such as wearable devices, but also technology that is placed around us in our environments, making our environments smart or intelligent environments. So based on this introduction and these three principles, I'm proposing this definition for a new type of reality called sensory motor reality, or sensory motor realities, if you will, based on the principles before. And I define this as dynamic manifestations of the reality that each of us subjectively experiences by associating perception and action in the mediation provided by wearable devices and smart environments. Now, the focus is clearly different from other types of realities that we can design today, because abilities are being emphasized. So a proper design space for such experiences will also emphasize abilities. So I'm going to briefly propose you such a design space that has a few dedicated dimensions, along which we can design new abilities, expand our current abilities, but also propose new interactive experiences to users as a result. So the first two set of dimensions, they refer to sensory mediation and motor mediation. And basically, these two dimensions, they specify both the nature and the amount of how much perception and motor action are being mediated. So you can have, for instance, extension, but you can also have amplification of senses. So for instance, amplification means that we can enhance current abilities to sense external stimuli, such as through better color perception, or in general, better perception of our visual world around us, if we take this example of the visual channel. And this can work as technology for people with visual impairments, for instance, as an assistive technology, but also for generating new experiences that all stay within what we currently have as abilities, the ability to perceive the world in the visual spectrum. But you can also have an expansion of these abilities. So for instance, it is very easy today to buy a thermal camera and connect it to a computer screen or to a mobile device, and you readily have the ability to see in the thermal domain. So this would be an extension of our ability beyond what our body normally or currently offers. And the same applies for motor abilities. We can extend or amplify our existing abilities. So, for example, this is a work called The Sixth Finger, which is a very nice piece of work where an additional finger was being prototyped, and it enables better grasp and also better holding onto objects, and also including larger objects that we could naturally support with our hands. And now, what is also interesting in this space is that opposed to amplification or extension, we can also have sensory diminution or even sensory contraction altogether. And there are practical reasons to do this. For instance, there is virtual training where people learn new skills by focusing on visual stimuli alone. So in this case, a hearing loss needs to be simulated. So there are no audio cues in order to keep the focus on visual stimuli. So in this case, the perception of virtual or the physical reality or the mediated reality around the user is purposefully diminished. And this also applies for our motor abilities. For instance, there are wrist braces that prevent the rotation of wrists for the treatment of the carpal tunnel syndrome and so on. And also devices that we can create, such as this device that was built by one of my PhD students. It is called Finger Hinter. And the main purpose of this device is to induce a movement on the user's index finger. And by doing so, it affects agency and creates a very interesting contrast between our intention and capability to move our body and an external device that moves our body for us. And it also offers the opportunity to examine what happens when a motor ability is refused by the system. So for instance, imagine a user that wishes to move a part of their body, but the system refuses it altogether. Then, in the continuation of the space, there are two axes that pertain to the world or to the characteristics of the environment in which senses are being augmented, expanded, or reduced. So on the horizontal axis, you see the established reality-virtuality continuum from Milgram and Chișinău, where you have the physical world at one end and we have the virtual world at the other end. But on the virtual axis, this is a new axis which I call imaginarity. And this axis encodes the degree of mental imagery that is needed for effective operation in the world. So for instance, we may need to rely on our memory in order to access physical information or to access digital information that we know is being placed in the physical world, even though we lack feedback of that information. And we've run several studies about this and came up with very exciting results. And finally, the instrumentation principle. So using technology in order to make all this happen results in two additional dimensions that can be used in order to create such experiences. So the horizontal dimension is what I call body augmentation, which specifies how we can use wearables in order to mediate all sorts of sensations and movement. And the vertical axis is about environment augmentation, where we integrate sensing and processing and visualization technology in the physical environment around us in order to mediate sensor motor abilities. So here in the environment, you have all examples of work such as furniture that changes shape and physical telepresence and reconfigurable environments and so on. So by combining by combining these two, you get to very exciting experiences. So in this case, so this is a project from approximately, I think, 9 years ago, where we played with a wearable device that delivers vibrations on the index finger that is connected to a personal device such as a smartphone, but can also be connected to a generic display in the environment. And in the interplay of wearable and environmental technology, we can encode visual information from the screen with vibrations on the finger. But all this information is being manipulated by the user using natural gestures and natural transfers across these devices, sometimes without seeing what was the main modality of presenting that information, which requires more than transferring sensory motor skills from the physical world, but actually adapting those skills and expanding our set of skills in order to really engage with such experiences. Okay, so now I'm going to discuss a bit about how this concept of space and the concept of sensory motor realities opens up the way to complement existing practice, an exceptional framework that we have today in accessibility computing called ability-based design, which basically says that designers adopt a stance where they focus on principles such as users' ability, accountability, the availability of technology, systems adapt to users' abilities, and so on. But in the context of computer-supported or computer-mediated realities, this is not enough. So the conceptual space and the concept of sensory motor realities gives shape to a total new paradigm in accessible computing, which I'm calling ability-mediating design. So ability-mediated design actually characterizes how sensory motor abilities can be amplified, extended, or rather contracted or diffused altogether in very different worlds, practically in a diversity of worlds that are essentially mixtures of physical, virtual, and imaginary. So what we can do in the physical world, what a computer can create for us in terms of stimuli, and what we can imagine. So our mental models of how everything works. So based on the conceptual space and the principles of mediation of world coverage and instrumentation, there are many practical ways of applying this new paradigm in practice. So in terms of mediation, this means that sensory motor realities that mediate perception and action can empower users with new skills and to engage in new experiences. Then world coverage means that sensory motor realities can take many possible forms of world existence, such as physical at the origin of the axis and virtual at the opposite end on the horizontal axis, but also combinations between the content that is imagined and content that is created virtually by a computer. And finally, in order to achieve this, in order to actually arrive at sensory motor mediation, all this needs to be instrumented by technology that is either on the body or within the environment itself. So mediation from within or mediation external to the self. So you have this new perspective where our entire lives can be seen as an evolving set of sensory motor abilities and corresponding skills based on those abilities. And now we have arrived at a point where we can actually plan for how these abilities can evolve and can expand according to context and according to our everyday needs, according to application requirements, and so on. And this has profound implications on how we act in all these new worlds that we can define. So in order to investigate such an exciting future, I have this vision for what will come next in terms of this possibility of creating new experiences in the context of sensory motor realities, and especially this framework of ability mediating design. So just imagine this future world where you can access on demand any sensory motor abilities you wish, such as downloading those abilities, and you can immediately start using them. Or those abilities can be automatically downloaded for you and integrated in your activities and integrated with how your body moves, how your body perceives the environment, even without you actually paying attention that your abilities have changed or have expanded or perhaps have contracted. So everything flows naturally for you, but you're actually experiencing this transition, this remarkable transition in terms of abilities. So I believe that there is a great diversity of new abilities and new skills and corresponding interactive experiences that can be reached within such worlds and actually become a reality for users with variety of visual abilities, including what I call today visual impairments or motor impairments and even cognitive impairments. And these opportunities would represent a direct consequence of actually and systematically applying a design space and a conceptual space, leading us to a variety of possible worlds to live in, to act within, and to perceive. Thank you very much for your attention. So we've started developing this concept a few years ago, and we're still trying to figure it out. We also have several other applications, but I know that time is limited, and I do not wish to take up any more of your time. Thank you very much for your attention, and I'd be very happy to answer your questions.